This is an application with analog input and digital alarming with the USB 6009 and LabVIEW. It's the same with any NI-DAC MX device. So I'm going to describe the setup for you, and then we'll get into programming our task with LabVIEW. LabVIEW is a graphical programming language that makes data acquisition setup straightforward, but also can be expanded for more complex applications. You can download the evaluation version of it at www.ni.com. So in our setup here we have the USB 6009, and it's got analog inputs and analog outputs as well as digital I/O on it. In my setup I have an LED over here that will be our digital alarm. It's being driven by a digital output line that comes through a resistor, and then the backside goes to ground on the USB 6009 device. Next to that ground is a 5-volt channel. It's just 5-volt power that comes out of the USB 6009, and I'm using that to power the high side of a potentiometer. The low side of the potentiometer is wired back to the ground of the USB 6009. Now in between the high and low side I have the potentiometer, and it will vary as I change the position of the potentiometer. That voltage, varying voltage, will come back to the analog input channel 0, and that's what we're going to read and monitor. So when that voltage goes above a set value, then we're going to light this LED. So now let's go over to LabVIEW, and we'll open up a blank virtual instrument, and we'll start from scratch with the front panel. The first thing that we want to do is click right, and we want to put down a waveform chart so that we'll be able to see our potentiometer voltage as we vary it. A couple things we'll do here is we'll change the range on the chart between 0 and 5 volts so that we can see the full scale between 0 and 5 from my potentiometer. I'll also tell it not to auto scale so that we can make sure that doesn't vary while we're acquiring the data. Now we'll go to the block diagram. Back here we see our icon for our waveform chart, but now I want to do analog input, so I'm going to click right, and we'll go down to our data acquisition assistant, which will allow us to configure our acquisition. So this opens up a dialog box that asks us some questions, and yes, we'll acquire signals, analog input, voltage, and we'll do it on a single channel, which is analog input channel 0, which again is connected up here with my analog input from the potentiometer. We're going to tell it to be plus and minus 10 volts because that's the voltage range of this particular device, the USB 6009. Our configuration for the input will be reference single-ended, and then finally we'll tell it to take a single sample on demand. We'll click OK, and we're ready to go with that. Next, what we want to do is wire the output of that data acquisition to our strip chart so that we can see this when the program runs. So that's all set and ready to go. The next thing that we would like to do is a comparison to a value to see if we need to issue a digital alarm. So we'll click right, and we're going to go in and do a comparison here. So we choose our comparison palette, and as you can see there's equals, greater, less than, and here's a greater than. That's the one we're going to choose, and we'll put it down. Now what we're going to do is take our data from our analog input, and we're going to wire it up, and then we're going to compare it to a value. So I'll create a constant here, and this constant we're going to set, and I'm going to choose 2. So anytime the voltage from our potentiometer over here exceeds 2 volts, then we'll get a true that comes out of this comparison. Next we need to go and generate our digital output. So we're going to click right, and we'll go back and get another DAC assistant, and we'll put it down, and this time we're going to tell it to generate signals. So we'll choose generate signals, digital output, and then on a single line, and then we're going to choose line 1 because right here I've chosen line 1 for the output. So we'll say finish, and in fact this is ready to go. So we'll say okay, we don't need to make any modifications there, and then we're good. So we'll take the output of our comparison, which is a true or a false, and we'll wire it up to our DAC assistant, which is digital output at this point, and that's going to go ahead and issue that alarm. The other thing that I would like to do is wire that 2-volt level up to my waveform chart and combine it with my potentiometer input. So if we just clean that up, you can see now I'll show you both of those on the strip chart in the front. Now we want to put a loop around it so that it runs continuously, so we'll grab a while loop, we'll put it around this, and then I need to tell it if I want it to stop, which at some point I probably do. So I'll create a control. Now I have an on-off switch on the front panel. Now we're ready to run this program. So we'll go ahead and we'll click run on this, and I'm going to go ahead and dim the lights so that you can see the LED when it lights up a little bit better. So as I turn this now, you can see that this changes position. It's going up and down a little bit, but if it gets up and it exceeds above our 2 volts, then our alarm comes on. And as soon as it dips back down again, our alarm goes off. So now we've gone ahead and acquired our analog input. We're doing our digital alarming, and it stays on or it stays off depending on the level that we're exceeding. So at this point we can go ahead and stop this program. You see that we've acquired data, we've charted it for you, we've hit our digital alarm levels, and this is how you do analog input with digital alarming with the USB 6009.